Probability, and this is, let's see. For the word I want here. You want to write that down. Probability of two independent events. Which means this. If I ask you, let's say we're flipping a coin. The probability, if you flip it twice, of getting a head and then another head. How often will that happen? When you flip a coin twice, how many times will you get head back to back? Or even the same thing if you flip two coins. Well, if you don't know, one way to figure it out is to draw a little tree diagram. We're not always going to do this, but for the sake of this, we'll do this here. All right, well, the first time, on your first flip, what's your probability? You can get a head or a tail, correct? Mm-hmm. On your second flip, after the first flip, you can also get a head or a tail. So your total possible outcomes when you flip twice is to get a head and a head. I guess I should put a comma there. Just put two H's. You get a head and a head, or you could get a head and a tail. Or you could get a tail and a head, or you could get a tail and a tail. These are all of your possible outcomes. So if I ask you to find the probability of getting HH, how many total different outcomes were there? 4. How many of them were HH?
1.
Just 1. My probability is 1/4 of getting a head and a head. Now you don't want to have to draw a tree diagram from all that, because what if I asked you the probability of drawing the Jack of Hearts and then the Queen of Spades? Let's see what's a spade look like upside down. All right, you don't want to spend your time drawing all 52 cards for the first draw, and then drawing 52 cards after that on a little tree diagram, because that'll take all of your time. So there's a helpful little shortcut to this, and here's what you need to write down. Pink. To find the probability of two independent events, and we'll talk more about independent later, just write it down, comma, here's the key word, you multiply their individual probabilities together. And you're going to have to listen to the explanation of it, because I don't know if the words will do that justice. To find the probability of two individual events, multiply their, did I spell that wrong? Yes. Their, P-H, whatever, E-I-R, I-E-R, individual probability. In other words, this. Let's go back to this one before we do the card one. If I want to know what the probability of getting two heads back to back are, it's the same thing as what's the probability of getting a head. It's the probability of getting a head the first time times the probability of getting a head the second time. Those two things time themselves. Probability of getting a head is 1/2. Probability of getting a head there is also 1/2. Multiply them together, you get the probability of both of them happening. So if you're doing the cards, you would take the probability of getting the Jack of Hearts and multiply that by the probability of getting the Queen of spades. Well, what's the probability of getting the jack of hearts? How many jack of hearts are there? How many cards are there?
1 out of 52.
Yeah, it's 152 to get the jack of hearts. What's the probability of getting a queen? 152. The probability of doing both of those is 1 over 1, which is 1 times whatever 52 times 52 is. Which is what? 104 and then 0, 10, 0, 26. 1 in 2,704, I believe. It's a pretty long shot that you're going to draw those two cards back to back. How about this? Let's look at another one. Let's say you've got a spinner cut into 4 parts, 1, 2, 3, 4, and you have a coin that you're flipping. Do a little Abraham Lincoln look here. What it would be the probability of spinning a 4 and then flipping a tail? Well, rather than writing the tree down and doing all those combinations, which you could do, it wouldn't take that long, you can just break this apart and say, well, the probability of both of these happening is the probability of spinning the 4 multiplied by the probability of flipping the tail. What is the probability of getting a 4?
1/4.
1/4. 1/4. And what's the probability of flipping a tail?
1/2.
1/2. The probability of both of those happening, 1/4 times 1/2 is,
1/8.
I'm sorry, 1/8. Not sure what I was looking at. 1 out of 8 times you should get both of those to happen back to back. Let's see what they ask here. One question out of the book says a coin will be flipped 4 times. What's the probability that a coin will land heads up 4 times in a row? So the probability of a head, a head, a head, and a head. The probability of that happening is the probability of flipping the first head times the probability of getting a head the second time times the probability of getting a head the third time times the probability of getting a head the 4th time. And as you know, each one of those probabilities is 1 out of 2, if it's a fair coin. So the probability of doing that, getting a head to flip, the coin to flip head 4 times in a row is 1 out of 2, 4, 8, 16. Not 1 out of 8, it's not 4 times 2, it's 4 2s times themselves. 1 out of 16 times you should be able to get that to happen. Is that not the most exciting thing you've never heard?
It is, Mr. Hunt.